Today we're going to look at solving radical equations and inequalities. So we want you to be able to do both here. The first problem on your note sheet says computer chips are made from the element silicon, which can be found in sand. Suppose a company that manufactures computer chips uses the formula shown to estimate the cost in dollars of producing N chips. What would the cost be to produce 27,000 chips? Okay, so 27,000, that's chips. That means we would want to put that in for N, since N is chips. So if we were to substitute that in, we should be able to solve it out. So we get 10 times 27,000 to the 1/3 power plus 1,500. Now to solve that, we want to make sure that we follow order of operations. So we want to start, is there parentheses? Yes, but they're simplified. Next, exponents. We do have an exponent here, so we want to do 27,000 to the 1/3 power. Two ways you can do that. You could actually just put it in as an exponent. We looked at this earlier in the unit. So you could just type it in as 27,000 and then hit your power button 1/3, and you can get it that way. Or we also know that power of 1/3, if you have something to the 1/3 power, that's the same as doing a radical 3 or cubed root. So you could also do cubed root, and it should come out to be the same thing. So if you did cubed root of 27,000, you get the exact same answer of 30. So that is what you would get when you do that. So now we got 10 times 30 plus 1,500. Now it's just going through and solving this out. If we multiply these, we get 300 plus 1,500. Adding it up, our cost would be, looks like $1,800. Okay, so you should be comfortable working with either notation. All right, so on number one, they want us to solve this out. Okay, so this equation, we want to get it down so we know exactly what x equals. Well, you notice that in this one, there is a radical in here. So our first goal is to get that radical by itself. So anything else on that side of the equation, we want out of there, which means our first step, subtract 2. So now we got square root of x plus 1 equal to 4 minus 2 is 2. Now our goal is to get rid of that square root. Well, we've talked about this before. Our goal is to undo any radical that you want to use an exponent, because really this is a power. So to undo square root, you want to square both sides. Squaring undoes square root. So now we have just x plus 1 left on the left side of the equation because our radical sign's gone. On the right side, 2 squared, 2 times 2 is 4. Now this is simple, subtract 1, and our answer is 3. Now, what you should be doing when you're done with these is just to do a quick check to see, does your answer really work? And the reason is, sometimes you will obtain what's called a extraneous solution. And that means that even though you got an answer, your solution doesn't actually work when you plug it back in. If that does happen, then you say that there is no solution. So let's see if it actually works. If we plug 3 back in, will we get this to equal 4? Well, let's see. If we put 3 in here, 3 plus 1, that's going to be square root of 4 plus 2. Does that equal 4? Yeah, I think it does, because square root of 4 is 2. 2 plus 2 does equal 4. This checks out. Our answer does check out. It's good. But do a quick check, because sometimes you do get extraneous solutions when solving these. All right, let's look at the next one here, number 2. All right, number 2, they want us to solve this one. Okay, a little bit harder. Okay, now we got square roots on both sides. Okay, so we want to look. What do we do to undo a square root? Well, we just talked about we want to square to undo that. But if we square one side, just like we did in the last problem, you got to square both sides. Now on the other side, that means since there's 2 things here, we're going to have to square that whole thing on the right side. So here, our square root and our power 2 cancel out. All that's going to be left here is x minus 15. On the right side, we got to multiply that out. Now, the common mistake made on something like this is to say that's going to be 9 minus x. No, that's incorrect. Okay, and you can see you can see that that's not going to work if we go by the definition of what it means to square something. If you're squaring something, that means you're multiplying it by itself. So if we multiply two of these together, would we get that same thing? Watch what happens. We would want to go through here. If you want to think of that FOIL acronym, multiply first, outside, inside, last. So 3 times 3 would be 9. 3 times negative square root of x would be minus 3 square roots of x. The inside ones would be minus another 3 square roots of x. And then the last ones, negative times a negative, it's going to be positive plus. And then square root of x times square root of x would be square root of x squared, which is just x. So simplifying this out now, we got x minus 15. Looks like these are like terms here. So that'd be minus 6 square roots of x. Okay, next thing we would want to look at possibly putting some of these like terms together. One thing I see we could do, we could subtract 9. Now we're getting some like terms together here. Okay, now we can maybe look to subtract an x. All right, look what happens here when we subtract an x. That cancels out. Looks like it also cancels out on the other side. So now we just made this a lot easier. Okay, now we want to get the 6 out of here. It's being times, so don't add 6. We want to divide by negative 6. Cancel that out. So now we got 4 equal to the square root of x. Okay, next thing we want to do is to undo square root, square both sides. Okay, that cancels out, so you just got x here. 4 squared is 16. Okay, so 16 is what we got as an answer here. Now again, check to see is that a solution. So let's go back to the original problem here. Will that work out? Does 16 work if we put it into both sides? Well, on the left side here, if we put 16 in, 16 minus 15 is going to be 1. Square root of 1 is 1. So the left side simplifies to 1. Does it work? Does the same thing happen on the other side? Well, here we got 3 minus square root of 16. That means we got 3 minus square root of 16 is 4. 3 minus 4 is negative 1. Does 1 equal negative 1? No, that does not work. This is an example of an extraneous solution. Even though we got 16 as our answer when we solved it, this one we would say has no solution. Because we got 16 as an extraneous solution here. So that's why you should do a quick check when you're done, because that does happen occasionally. All right, number 3. Let's try another one here. We want to get this by itself. So first thing, add 1 to both sides. So now it's equal to 6. Now we got to undo the square root. So square both sides. Squaring and square root cancel out. So I got x minus 2 equals 6 squared. 6 times 6 is 36. Add 2. Answer's 38. Okay. Again, plug it back in just to make sure it works here. We put 38 in there. 38 minus 2 is 36. Square root of 36 is going to be 6. 6 minus 1 equal 5. Yep, that one checks out. All right, let's look at number 4. All right, now they're throwing something new at us here. Now we don't, even though it's not a radical, it kind of is, because this is power 1/3. Okay, but your goal is still the same. We want to get this exponential or radical here by itself. So start by adding 2 to both sides. Okay, we want that gone. That's going to cancel that out. So now we got 3 times 5n minus 1 to the 1/3 power equals 2. Okay, we still don't have it by itself. We want that 3 out of there now. It's being multiplied, so divide both sides by 3. Okay, so now we got 5n minus 1 to the 1/3 power equals, since 3 doesn't divide into 2, rather than writing 0.6, or it's really 0.6 repeating, Rather than go that route and start dealing with decimals, I'm going to leave this as 2/3. Let's leave it as the exact answer. Okay, so now how do we get rid of this exponent? Okay, we do not want to now do +1 or anything like that because we can't. That 5n minus 1 is stuck in the parentheses when there's an exponent there. So to undo an exponent of 1/3, we want to do reciprocal. Okay, and the reciprocal of 1/3 is, reciprocal of 1/3 is 3/1, or just 3. So we want to take both sides here to the power of 3. So we're going to, both sides here are going to get taken to the third power, because 1/3 times 3 is 1. So now that's just to the first power. This is just 5n minus 1 on this side. On the other side, we want to cube 2/3. Okay, well, we know from some of the exponent stuff we did, if you're taking a fraction to the power, you want to take that power to both the numerator and denominator. So we want to cube both the top and bottom. So let's see what we get when we do that. 2 cubed, 2 times 2 is 4, times another 2 would be 8. On bottom, 3 times 3 is 9, times another 3 would be 27. All right, now this is a problem we should be able to solve here. It's got a fraction, but we should still be able to do it here. Next step, add 1 to both sides. Okay, so now if we add 1 here, we got to figure out what's 8/27 plus 1. You could do it on your calculator. Now, if you want to do it without 1, you'd need a common denominator here. So 1 would, in this case, would be the same as 27/27. So add it with a common denominator here of 27, we should be able to make that a fraction by adding the numerators. 8 plus 27 is 35. Okay, last step now, we want to divide by 5 here and see what that equals. Now, since we got a fraction on the other side, rather than dividing by 5, we could also multiply by the reciprocal. The reciprocal of 5 is 1/5. So we could times both sides by 1/5 too to also cancel that out. So now we could figure out the answer by simplifying that out. Well, I see if we got a 5 on the bottom and 35 on top, 5 goes into 5 one time, goes into 35 7 times. So it looks like the final answer in this is 7/27 would be the final answer for this problem. Okay, so that's an example of what you should do if you got a fraction power. Here's another one that has a fraction power. Now, again, we know this is the same as, another way you could write this is the 4th root of 2y plus 6 minus 2 equals 0. So you can think of it either way. Whatever way makes more sense for you, you can do that. But either way, our first step here should be to add 2 to both sides. We want that gone. Okay, so now we get to the point we're kind of stuck because of that exponent. What should we multiply, or what power should we take to both sides? Reciprocal of 1/4 is what we should do. Reciprocal of 1/4 is 4. We want to take both sides to the 4th power. Another way we would know that, if you have the 4th root, to undo a 4th root, you would take both sides to the 4th power. So that's what we want to do here. So now that cancels. This side's just going to be 2y plus 6. On the other side, we got to figure out what's 2 to the 4th power. 2 to the 4th power is 16. So now this is a pretty easy one to solve. Minus 6 from both sides. Divide by 2, and we get 5. Again, though, make sure you just check the answer. Make sure it works. If we plug that back into the original problem, we can see if that's a solution or not. So if you put 5 in here, 2 times 5 would be 10, plus 6 is 16. So if we do 16 to the 1/4 power, minus 2, does it equal 0? Let's double check on our calculator, see that that works. 16 to the 1/4 power. I'm hitting over, so it gets off of that. Minus 2, does that equal 0? Yep, answer checks out. 5 is the answer. Let's try another one here. Why don't you pause the video, see if you can try number 6 and see what you get. All right, let's see how you did. Should have hopefully started by subtracting 5 here. That leaves us with this. Okay, now how do we undo power of 1/3? We should take both sides to the third power. If you want to think of it as cubed root, you could do that too. Either way here, though, we should be taking third power because that's going to undo this. Or if we do third power here, that undoes that. So now you got 3y plus 1 equals negative 5 to the third power. If you type that in your calculator, you're going to get negative 125. Now minus 1 from both sides. And that should be negative 126. Divide by 3. And the final answer you should get is negative 42. And you should, again, check, plug it back in, make sure it checks out. This one actually does check back out. All right. Number 7, now we get into some inequalities. Remember inequalities, that's where you have one of these less than, greater than type signs when you're doing the problem. So just some things to remember when you're doing inequalities. Anytime you multiply or divide by negative, make sure you flip the sign around so that it comes out right. All right, but basically you solve these the same way. We want to get the square root by itself. So start by subtracting 2. Get that gone. Okay. Now we're stuck. We can't do anything else because of this radical sign. But to undo that, we would square both sides. That gets rid of the square root. So you got 4x minus 4 less than or equal to 4 squared. 4 times 4 is 16. Plus 4 to both sides. And divide by 4. And it looks like we get that x has to be less than or equal to 5 for our answer. Now, you got to be a little bit more careful with some of these inequalities because that looks like a pretty solid answer there. Anything less than 5, though, means any number smaller than 5 should make our statement up here true. Well, 5, if you put it in, it works. It's going to be fine. Let's try some other numbers that we know are less than 5. What if we would put 2 in here? Would 2 work? Okay, well, 4 times 2 is 8. 8 minus 4 would be 4. So now it's 2 plus square root of 4 here should be less than or equal to 6. Well, we know square root of 4 is 2. 2 plus 2 is 4. We get 4 is less than or equal to 6. Yeah, that's a solid answer. That works out. 4 is less than 6. Does everything work, though? Let's try 0. 0 is definitely a number that's less than or equal to 5. So according to this statement, 0 should be an answer. What happens if we put 0 in there? Well, 4 times 0 is 0. Uh-oh. That means what's under our square root would be square root of negative 4. Can we do square roots of negatives? We can't get a real answer from it. So not everything less than 5 equals 0. Only certain numbers less than 5 are going to make this true up here. What we're not considering is what's the domain of this function? What numbers can we actually plug in for x that this will work out? Well, remember before from graphing some of these square root functions, to find the domain, you want to take whatever's underneath the radical sign and make sure that that part stays bigger than or equal to 0, because 0 is the smallest number you can take the square root of and still get a real answer. So if we solve this out, add 4, divide by 4, it looks like in order for you to actually get an answer from that equation, we need to make sure x stays bigger than or equal to 1. As long as x is 1 or bigger, we can actually solve this. If it's smaller than 1, you can't even solve that equation. So now what we want to do in this case is link these two answers together into one solution and write a compound inequality. So our answer, we can put x in the middle. We know it has to stay less than or equal to 5, but we also want it greater than or equal to 1. Well, to write that here, if we were to switch these two things around here, 1 and x, we want it pointed at the 1. That means it should look like that. there's our compound inequality saying that anything between 1 and 5, including those two numbers, would be solutions. So with inequalities, you've got to sometimes check the domain and make sure that the domain stays true with these. Let's try another one. Number 8 is another inequality one here that we want to try out. So let's see what we get on number 8. So first thing you want to do, get the radical part by itself. Subtract 1 from both sides. Oh, minusing 1, so that should be 4. Okay, now we're stuck again, so undo square root by squaring both sides. That's going to cancel this out. 4 squared is 16. Okay, now we can solve minus 2 from both sides. Divide by 2. We get greater than 7. Okay, domain on this one is that we need whatever's under that square root to stay bigger than or equal to 0. So if we solve this, minus 2, divide by 2, looks like x has to stay bigger than negative 1. Well, should we put these together in for our answer? Well, if you look at our original thing here, it said that x has to stay bigger than 7. Okay, if x has to stay bigger than or equal to 7, that means the answers are going to be like 7, 8, 9, 10, or even any decimals in between, like 10.1 or 10.25 or anything. As long as it's bigger than 7, these are all answers, and there's infinite answers here. Are these answers bigger than negative 1? Yeah, they are. They're all bigger than negative 1. So in this case, even though our domain says it has to stay greater than negative 1, we don't need to necessarily include that in our answer because our answers are already all bigger than negative 1. So in this case, just that would be our answer. So the answer to this one is just x has to be bigger than 7 because all the answers are already making this true. So you don't need to include the domain if your first answer already includes that as part of it. Okay, number 9. Let's try this one. Again, start by getting the radical part by itself. Okay, now we got to undo this by squaring both sides. 6 squared is 36. Add 4 to both sides. Divide by 4. Looks like x has to stay less than 10. All right, we got to check domain though. What's our domain going to be here? And in this case, we want to make sure this stays bigger than 0. If we add 4 and divide by 4, it looks like x has to stay bigger than 1. Well, here we do need to include our domain with our answer because less than 10, we could run into some problems here where numbers less than 10 could end up being not greater than 1. So if we link these two together, our answer is that it has to be less than 10 and greater than 1. That's the final answer for the problem. All right, why don't you pause the video here, try out this number 10 one on your own, see what you get for that one. All right, let's see how you did. If you solve this out, you should have started by subtracting 4, then square both sides. And if you square both sides, you're going to get that 3x minus 6 has to be less than 9. And solving this out, you get that x is less than 5. Make sure you do check domain on this one because it does matter. The domain is going to say that that part under the square root has to be bigger than 0. And if you solve this part out, domain's going to have to make sure it stays bigger than 2. So putting that together would give you this answer. Anything in that range would make this true, and you'd be able to solve it. All right, very last problem. Says the ponderal index, P, is a measure of a person's body weight based on height, h, in meters, and mass, m, in kilograms. That formula is as shown. A 70-kilogram person is 1.8 meters tall and has a ponderal index of 2.29. How much weight could a person gain and still have an index of, at most, 2.4? Well, a lot of information there. You want to, especially in problems like this, if they give you a formula, probably going to need to use that. Okay, so let's look at our formula here. And then I would focus in on that last question because the question is going to tell you what you're looking for. How much weight could a person gain and still have at most a ponderal index of 2.4. Well, what is that 2.4 talking about? That's the index. Which of these variables was the index? The index is P. So we want to put this in for P. Okay. The other thing we see on this one is says how much weight. Weight is what we're solving for. Which variable is weight here? Well, the weight is the mass, m. So what we're trying to figure out is what should m be. That means we should know the person's height somewhere in this problem. So what is the person's height? It looks like the person is 1.8 meters tall. That means we should be putting that amount in for h. So if we substitute this in, 2.4 equals the cubed root of m over 1.8. So if we solve this out, it should give us the mass that this person could gain and still have this. So if we solve this out, it's being divided here, so let's times both sides by 1.8. So now we got the cubed root of m equal to, let's see what we get when we times that, 1.8 times 2.4 gives us 4.32. Okay, how do we undo a cubed root? We want to cube both sides. Take both sides to the third power, and that eliminates that, so we're left with just m. So now if we do 4.32 to the third power, it should give us our answer. So now take this number to the third power, and that's our answer. So it looks like 80.62 about kilograms is how much this person could weigh to still have that ponderal index. Now, you got to kind of look at the answer on this one to see. It says how much weight could a person gain and still have, or how much could this person gain and still have a ponderal index? Well, this person already weighed 70 kilograms. So to answer the question, we should subtract that then to figure it out. So if we take that minus the 70 they already weigh, it looks like this person could gain up to this many more kilograms and still maintain that ponderal index. All right, try some of these solving problems out on your own then and see what you get.